Welcome back to Further Solutions Academy. Further Solutions Academy. On this video, I'll be walking you through on implicit function. Don't forget to share and subscribe to this channel, Further Solutions Academy. And at this point, you can learn any topic of your choice: mathematics, physics, and chemistry. Over 500 videos are here already. You can come and learn without any problem. Now, on this video, I'll be working on implicit function, which is we have been on differential calculus. We have been on introduction. We have done introduction. We have done first principle. We have done the basic differentiation, which is techniques or rules. We have done the rules that guide differentiation. The last video was quotient rule, which all the rules, function of function, product rule are ready available for you now. But on this video, I'll be working on implicit. When we talk about implicit, all what we have been doing in the previous video, they are implicit. They are implicit, and I've told you that y equals to s plus m. This is a what? Implicit. This is implicit function. Now, when I have it in form of xy plus x plus 2xn, equals to 7x. This is called implicit function. Please take note of that. Very, very important. Now, take note of this information very well. Now, you will see more of this when we are talking about ODE. Ordinary differential equation, ODE, ordinary differential equation, which will be fine with it, of degree 1, degree 2, and so on and so forth. Now, but in this video, what I want to work on, take note of that, very, very important. Now, by now, we should understand what is called product rule. Now, our product rule helps us to explain what is called implicit function. Now, for instance, if I have y s squared plus 1x equals to what? Okay, equals to 0. Find dy, the x of this thing. Now, what I just need to do is that this is u, this is what? V. Take note of that. Now, don't forget that u, the v, the u, plus v, the u, the x. Whatever you just need to do, this one will give us this. Look at this. Differentiate y. Anytime you differentiate y, dy, the x, which is going to be, sorry, let me explain this thing very well. Now, I want to differentiate this. What I will just need to do, I want to differentiate this one first and return this 2xy plus, I want to differentiate this now. This is my y. Anytime I differentiate y, you will just have x squared dy dx. Let me put plus y, let's say, also here, plus y equals to 0. Now, I want to differentiate this one plus 1. I've differentiated, this one is differentiated. Now, I want to differentiate this thing now. This is plus. Now, this one will be plus dy dx equals to 0. Now, anytime you differentiate x on the product or whatever, any line, you have to attach the y, the x to it, because I've told you that y equals to x. One is what? This is called dependent variable. Now, why this is called independent variable? Independent variable. Please take note of that. Very, very important. Now, that is why anytime you differentiate this, you have to attach the y, the x to it. Now, for me to continue with this, I will have what? X squared dy dx plus dy dx plus 2xy plus 1 equals to 0. Now, I can now say that what? X plus 1 bracket of dy dx equals to 2x y plus 1 or bracket of minus. This goes to the other side, which I'll be having dy dx equals to minus 2xy plus 1 divided by what? X plus 1. That is what that will give us. That is all about that. Now, I have some problems here, which there are many of them. Just to explain the parts very well, the topic very well, which is an implicit function. Very well. Implicit function. Now, I'll be writing some questions out, YX standard, and that will really help to learn this particular topic very well. Permit me to write that. Okay. Okay, let's play around with these 3 questions. This is number 1. This is 2. This is 3. This can be GC, YX, anywhere you can find this. Let's try to work around with it. Solution to this problem. Now, look at this. I have 2x cubed y squared minus 3x y squared equals to 4. Now, don't forget uv. Now, at this point, I will have to brackets of differentiate x, which I'll be having 3x squared y. That is very correct. Now, differentiate y, it will be plus 2y x cubed dy dx. Now, when I differentiate my x, I will attach dy, the x to it. Now, minus, I have my 3 like this, open another bracket, differentiate this, I will be having y cubed, squared. Now, plus, differentiate y now, it will be 2y x dy dx equals to 0, because this is a constant which is going to be 0. Now, can you see the way I handle it now? If I want to do it, I will now open my bracket, which I'll be having 6x squared y squared plus this multiplied by this, I'll be having 4yx cubed dy dx minus this will be 3y squared and minus 6yx dy dx equals to 0. Now, I think I've successfully opening my brackets. Now, the next thing is I want to collect like terms. Now, which I can see that 6x squared y squared minus 3y squared, this and this are friend, and plus 4y x cubed minus 6yx bracket of dy dx equals to 0. Collect like times and factor out this, out of the stuff. Now I can ask that what 4yx cubed minus 6yx close bracket of dy dx will be equals to minus bracket of 6x squared y squared minus 3y squared. This is yes, minus 3y squared. Now, can you see? I just bring up what is here to the other side of the bracket, which of the equation. Now, I will now divide both sides by what? By 4y x cubed 6y x and 4y x cubed 6y squared. This will cancel this. Now it means the x equals to minus 6xy squared y squared divided by 4y x cubed. Now that is my answer. That is my answer. Please take note of this. If I have xy squared is not the same thing as xy all squared. These are not the same. Or if I'm having something like this, now this part shows that only s are squared, but this part shows that s and y own square. Please take note of that. Take note of that very well. Take note of that very well. Now, I think that one is settled. That one is settled. Now, another one that you need to work on. Look at this particular problem. Solution to this problem. Now, look at this. I will turn it to what? 2xy squared. It means at that point I'm differentiating x plus 2x squared y dy dx. Now at this point I've differentiated my what? My y with respect of y, which is this one produced by this. I'll move on to the next one, minus 3. Now this one will be bracket of, I will be having y plus x dy dx is being produced by this. Now plus, permit me to move this to this side, bracket of, differentiate, which is going to be y cube plus 3xy squared dy dx. Can you see? Now equals to 0. Don't forget, this is 1. Now equals to 0 because this is the constant value. Now, since I have this, I can now say that what? 2xy squared plus 2xy dy dx minus 3y minus 3x dy dx plus 4y cubed plus 12xy squared dy dx equals to 0. Now, the one that has an ordinary number, which is squared minus 3y plus 4y, this one will now be plus, open bracket of, I have 2x squared y plus, this is going to be minus 3x plus 12xy squared dy dx equals to 0. Now, can you see now? I can now say that what? 2xy squared minus 3x plus 12x bracket of dy dx will be equals to minus bracket of 2xy squared 3y, hope I'm not making any mistake. Okay, 3y plus 4y squared equals to, okay, that is equals to that. Divide both sides by what? By this 2x squared y minus 3x plus 12, which is 2x squared y 3x plus 12x, which this we cancel this. Now by so doing that, I think I've done it well, which is this will be squared, y squared will be here, y squared will be here. Now my answer will now be dy dx will be equals to minus 2xy minus 3y plus 4y squared divided by, this will go in bracket, 2x squared y minus 3x plus 12xy squared. That is my answer. That is my answer. Now the last part of it, which is the last part of this part, which we need to. Now look at the solution to this problem. This is very straightforward. When I differentiate my heads, I will have 3x squared. Now, plus, this one will be 3y squared dy dx. That's very good. Now, it will be equals to, this will be 2 bracket of y plus x dy dx. Close the bracket. Now, don't forget, anytime I differentiate with respect of x, you have to attach the y dx to it because it's dependent variable. Now, I can answer that 3x squared plus 3y squared dy dx equals to 2y plus 2x dy dx. Now, this and this are friends. I can say that 3 y squared dy dx minus 2x dy dx equals to 2y minus 3x squared. I think I just collect like times. Now I can now say that what? 3y squared minus 2x bracket dy dx equals to 2y minus 3x squared, which I will divide both sides by what? 3y squared, 2x, and 3y squared, 2x. This will cancel this. Dy dx equals to 2y 3x squared divided by 3y squared. Now, that is all about that. I would like to show some cases, like one. Okay, there are some questions that you will be given when the gradient is at this point. What will you do? Now, let us try to work on that, and this should be able to illustrate that. Okay, permit me to write this question. Okay, for instance, look at this problem. You are talking about something like this. Okay, find the gradient. Gradient, this can be represented by gradient. Find the gradient of the function. This is the function. Sorry, permit me to rub this. Of the function x squared minus 2xy minus 2y squared plus, minus 2x equals to 0. At the point 1, minus 4. Now, let's try to work on this. This can be a problem which you need to learn how to handle. Now, what is unique here is this particular statement. At a point, gradient. Gradient also the same thing as what? Dy dx is also the same thing as gradient, which I've explained that earlier. So the same thing as slope. Okay, it's also the same thing as y prime. Don't forget those things. Now, if I have something like this, what you just need to do is that I'll be having x squared, 2xy, 2y squared, 2x equals to 0. Now, differentiate this, I will have 2x. How do I differentiate? This one will be minus 2 bracket of y plus x dy dx minus 2, minus 4, 2 is coming to meet that one, y dy dx, and minus 2 equals to 0. I've successfully differentiated. Now, I think at this point, I can now turn this to, this will be 2, this will be 2y, which is going to be minus here. Because I've opened brackets immediately. Now, since I've opened my brackets, I can now connect like signs. This, and this are friend, which I'll be having 2x minus 2y minus 2 minus, if I want to do it, I can say minus 2x 4y bracket of dy dx. Here will be plus, because I'm just opening brackets, I just erase bracket there, equals to 0. Now, this will move on to by saying that what? 2x plus 4y bracket minus dy dx equals to minus bracket 2x 2y 2, which I will divide both sides by what? 2x minus 4y, 2x minus 4y. This will cancel this. Now, dy dx, is there minus there? No. Okay. I will be having minus here. Please take note of that. I will just be having minus here, which is going to be minus, we cancel minus, which I'll be having plus 2x 2y 2 divided by 2x 4y. Now, at a point this, find the gradient of the function at a point this. It means at a point x, permit me to rub the upper part of this question. sorry. Now, at this point we are referring to, now at the point this, it means at point 1 comma minus 4. It means I'll be talking about dy, dx will be equals to xy. X equals to 1 and y equals to minus 4. It means I will come here, I will be bracketing 2 bracket of 1 minus 2 bracket of minus 4 minus 2 divided by 2 bracket of 1 minus 4 bracket of minus 2. Now, which I will be having 2 plus 8 minus 2, which will cancel themselves, divided by 2 plus 8, which I will be having 10. That will be 8 all over 10, which is equal as what? 2 all over 2 here for 4 all over 5 dy dx, which is called gradient, is 4 all over 5. That is my answer. Hope I'm getting the right thing. 4 all over 5. Now, it should be 4 all over 5. Okay, hope there is no any problem of sign. Is there any problem of sign? This will come to that side. Okay. Okay, that is all about that. That's all about that. Don't forget to share this video across to your friends. Once again, thanks for watching.